Okay, hope you see the slides. Is it? Please unmute and say.
Yes, ma'am, we can see the slides.
Okay, the next clustering method we are going to discuss, that is density based clustering method. As we discussed earlier, hierarchical based clustering method. For that, we two types of clustering discussed: agglomerative discussed, hierarchical clustering, and divisive hierarchical clustering. Is it? Then density based clustering method, the clustering, that is classification of similar type of objects together. That is the basic idea behind the clustering concept. Density based clustering method, this is detects whatever the shapes which we are going to relate or merge or to form the cluster of different objects, and it is separately identify what will be the outer layer or what will be the noise condition. So, without the noise or to avoid the noise, how clarity or how we clearly form the different clusters by using density based clustering. So, these are the common algorithm which is used to density based clustering techniques. We discussed here. DB scan is the method or first density based clustering algorithm. So density based spatial clustering of application with noise, that is called the DB scan algorithm. So it is able to find arbitrary shaped clusters and clusters with the noise. So here, when a group of individual objects are there, based on this object, or we need to form clusters, but there are some noises. So here we need to form the clusters or to avoid the outer layers separate or to avoid the noises separately, and we need to find out the clusters with more clarity. That is the idea behind the DB scan clustering method. Okay, so if we want to form a high density based clustering, we can choose DB scan method. So here there are set of data sets will be there by means of by using of different types of partitional based clustering or hierarchical based of clustering, we can form this type of similar clusters. Here the green part, it contains some nodes, and red part contains some nodes, and again blue part contains some nodes, again separate color is needed to, or it will be the separate range of another cluster. So this is the way which we identified or to form the clusters in the K-means algorithm or a hierarchical clustering. But in the case of DB scan algorithm, these type of clustering with more clarity which we can create. In the center side, this is the DB scan or the density based clustering algorithm. With a similar type of clusters, it will be grouped together, and its outer set or it will be the another set, that will be the common set which will be circulator, or it will be formed the cluster, and it will be denoted as like the second circle, and third circle it will be formed another type of circle. Other than that, what are the different kinds of colors which will be shown outside the red circle, that will be the noise part or the outer layer part. So some more clarity, we can group or cluster the object in the DB scan approach. Okay, so in the DB scan requires two parameters. One is epsilon, is the epsilon parameter, and minimum points, that is another parameter. For the epsilon, what is the radius? We need to draw a circle concentrated on each point. There are certain points or clusters point we need to create. So in the input side, we can have so many points. Based on each point, we need to draw a circle. That the radius, it is known as epsilon. That the radius which we want to draw the circle focused on or to centered by each object, that is the radius value or epsilon value. Then minimum points is that when we draw a circle, Inside that circle, whatever the minimum number of data points which we required inside each circle, that is the variable called min points. So in this DB scan algorithm or a density based algorithm, we can have minimum of 3 points it should need inside a particular circle. So these are the two variables which we need to implement the DB scan algorithm. These are the basic requirement to implement DB scan algorithm. Epsilon is the radius, min point is the minimum point, that minimum data point which we need to require or which we require inside the circle. So here, this is the circle drawing mechanism. When we have the points A and B, we concentrated to A object and draw 1 centimeter epsilon, that is the radius which we draw a circle. This is again B point, we need to draw the circle. We need to concentrate the circle part or the center point of the B. From that point, we need to draw 1 centimeter circle. So here, the third figure in bottom part, A, B both are drew. Then both the values, here the data values inside the circle A, it contain 3 points, B contain only 2 points. That means minimum point, the data, minimum data point that a circle required, which is the min points value, that is equal to 3. Is it? So this is the way we draw the circle up to the radius and mark the minimum points. So DP scan categories the data points into 3 categories. One is core point, another one is border point, then next one is noise point. Again, we need to draw the circle. In each circle, we need to draw concentrated or focused on each data point. On center-wise A, with the epsilon value 1 centimeter, we need to draw the circle. For the A circle only, it contains 3 points. Is it? What is the A circle which need to be concentrated? That means we have to draw focused the center point A, and with 1 centimeter radius we need to draw a circle. Inside that A circle, it contain 1, 2, 3 points. Is it? So we need to require, or we need 3 other minimum point value which we need inside a particular circle. So here we have 3 points. Is it? So that's why the point it will be called core value. When a circle satisfies its minimum criteria, or from starting from 3 to maximum anymore, so minimum value it should be 3. When a circle it reaches 3 points, it will be called it as a core point. That particular point it will be called a core point. In the case of B, the next we want to focus B, then we need to draw a circle with epsilon 1 centimeter. Is it? So here, concentrate, already we made A as core point, then B focused on B, we just draw another circle. It contains 3 points also. So B is also a core point. That's why it marked as red color. Okay. When a circle or a point it contains 3 minimum point, it will be called the core point. Then we faced or focused on C. We need to draw the circle with the 1 centimeter. It contains only 2 points. That is A and C is there. It is the border range of the core point. That's why it is called border point. It will be colored like blue color, that is border point, that it will be notified as blue color. So here C focused, it draws a circle, then it contains 2 points, that's why the border range of the core point, so it will be made as border point. Then we focused D, we need to draw a circle. Again, the circle it contain D and B nodes or at 2 points. Then the D point or a circle that will be marked as border point because 2 is border range of the minimum point 3. Then we selected E. E is when we focus on E, then with 1 centimeter we drew one circle, then that circle it only contain one point, that is only E. So here that E will be called the outlier or the noise value of this particular graph formation. So that's why we colored it as in pink color, that is noise point. Here A, B, C, D, A, B are core point, C and D are border point, and E is noise point. Is it? Then, what is the definition of core point, border point, and noise point? A point with the minimum of number of data points, that is called a core point. Will be the border range, it is called border point, and it will be the outlier or the not attached with the core point or a border point, that will be called the noise point. Then density reachability, the another term that is related to density based algorithm. Density reachable, that means directly or indirectly one point to another point, that how it will be related. Is it? So here the D point, D is directly density reachable from B point. Is it? That is B moved the right, or direction that will be notified or denoted like from B to D. Is it? So that's why it is called a directly density reachable. In case of the node C, it will be reached to the point D by through C to A to B, B to D. So indirectly, the density reachable from C, which node? The D node is indirectly density reachable. So density connectivity is the another term. Here, the P point in the figure itself, from the P point, it is the center point. Again, the P to R, P direction, then right direction, it will be notified R. And from the P, it will be a left pointer and a left arrow direction that should be reached at the point S. So here, the points S and R density connected. If it means that it will be a density connected or density reachable from P to R and P to S. From the point P, R and S are called density connected points. So DB scan algorithm, which we want to, or if we have the input data set D and we have the epsilon and minimum points, then these are the two parameters to apply the DB scan algorithm. And each point P, it will be marked, it need to be marked core point or a border point or a nose point. Then based on this core point, we need to find out the cluster. These are the algorithm for the DB scan algorithm. By using one example, we can explain how the DB scan algorithm for the density based clustering method, what will going to happen. So here the input table which contains some of the data set. This is the initial data set with the matrix or data matrix with the value of A, B, C, D on the row side, A, B, C, D, E, F in the column wise. So these are equal number of rows and equal number of columns. That type of matrix we formed for the density or DB scan algorithm. Here the problem used with the minimum point equal to 3 and epsilon is less than 1.5. So we need to draw the circle. If we dramatically or pictorially we represent the DB scan algorithm, the direction or the circle which we draw from each point, the distance or radius that should be less than 1.5. So here the values A, B, C, D, E, F, these are the different points. From these points, we could have to combine the clusters and form the clusters. how these clusters will be formed. From each column, we should look for the minimum points criteria with the epsilon less than 1.5. Here, from the A column, it contains less than 1.5. That is the threshold value we can put. Based on this value, epsilon value or the radius value, we need to circle the values which be under the or the less than the radius value. So here from the A column, below 1.5, 2 points are there. One is 0 point and another one is 0.8. These are the A column value corresponding to epsilon less than 1.5. From the B column, it contains 0.8 is the first value, 0.2 is the second value. Then again, we checked that less than 1.5, only these two values are. So here we form 0.8, 0.2 from this graph. Then the node C or an object C, we could have the values 0, 2.1, 1.4. These are the values corresponding to the C point. Is it? So here there are three values in the C column. So here they satisfied minimum 3 points. So after this formation, we need to measure each point. That means we draw a circle. Inside that circle, we checked whether the minimum points it contain 3 points. So after using, or we can use only this type of point values, how it will be measured. We cannot do the circle. We only do by from each column we need to filter the value or what are the different values less than this epsilon value. So we need to circulate. From that column, we need to check if whether that column it contain less than 3 and greater than 1. That will be the condition border point, or it will be less than 3 or it will be 1. That will be the noise node. And if it will be contain minimum 3 points, it will be called the cluster point. So our core point, that is the concept we need to implement by using this table of data values. So here the values A contain two values only, that is less than epsilon 1.5. So here we circle the two types of minimum value 0 and 0.8. Only 2 points will be there. So then we cannot ensure about it will be board point or noise point. That's why we simply write that B bar now board point bar noise point. Then again B column we checked the values or data points. If there are some values with less than 1.5, it will be circled, and from this circle whatever the values with the minimum count and minimum number of points that will be reached, it will put it is the core point, otherwise it will be put as board point or the noise point. Here only two values under the B column, so that's why we put board or noise. We couldn't identify, that's why B bar N we notified. In the third column, C column, it contain only two values, that is which value less than 1.5. So here two values are there. So based on this points or data points, we need to identify the C node. It will be board or noise. Then the D point, that is the fourth point, we need to analyze the values inside the D column. Here we got 0, 1, 0.6. These are the three values which are less than 1.5. So based on these three values, we identified that D is the point which contain three minimum points. That will be the criterion or condition for core point. Is it? So that's why in the above row, we put C in the above of the D value. That means C is the core point. Then again, we need to analyze the value of the column E. Is it? So here, the less than 1.5, that should be 1.4 is there, 1 is there, 0 is there, 1.2 is there, 4 values will be there. So 4 values may be, it means that it greater than minimum points, at least we needed 3 minimum points. So 4 is measurable. So then we need to make E node or E point as the code point, the core point. Then the next value, F, under the F column, it contains 3 values less than 1.5. Each value we form a circle and count it. And after this count of 3 points, we need to make F point as the core point. Is it? So these are the first initial classification. Whatever the node or whatever the point which contain 3 points or above 3 points, it will be made as the core point. Other nodes which will be made to board or noise. We need to know. We need not know which is the board point or which is the noise point. That will be not aware to the particular user. So for that fixing, so to maintain some clarification on the board point or the noise point, we need to check with the corresponding value of the core point. So here we can check, here the values, we can have B bar N under the C point, is it? Here the value which is higher than or relatable to 1.5, that will be chosen, is it? So 1.4 is the value we chosen. That value is included in which column? E column, which will contain. That means E column which contain 1.4, that is the highest point under the C column, which we want to change the board point or the noise point into some other point. Is it? So here the 1.4 is the higher value that will be given under the value of the column E. So here we need to check the E node point. In the E node above row, it is pointed as C or core point. That's why we need to change the board or noise point of the C column, that should be changed into core point. So here C column, that is will be changed to the board point, is it? So that what is the reason? It contain no 3 points. The criterion is to the core point, that is minimum 3 points it needed. But to finalize the value to B or N, we need to clarify that it is B or it is N. For that only, we need to find out the topmost value or the highest value from the particular column, and which column, that value included in which column, that column contain core point, so it will be near to the core point. That is the area which is called a board point, is it? Then again we need to convert the B bar N of the B. So here the value 0.8 is the highest value under the B. So here 0.8 value is included in A only, A column only, is it? So here A is already board or N, that is not no. So in case it is not the core point, so that's why it will put the noise point. So here the B column we changed to the noise point. How it will be changed? The comparison table for the topmost or the highest most value or highermost value, that is 0.8, that should be under the A column. A column we could not aware about which is board point or noise point, but here this is the maximum value which contain under the B. It is not, it is A, so it is not the core point. That's why we put B as noise point. Is it? Here in the case of C column, we identified the highest value that is under the E column, that is a core point. Only that case the C point make B. That means it is the border point of the core point. Is it? Then again the node, the first node a, we need to fix B bar N, B or N. So here there are two values only, 0 and 0.8. Here 0.8 is the highest value. It is or it will be given inside the A node. Is it? Inside the A node or B node only. So here B node we already changed to noise node. So here the node itself we form as the noise node. So A to F, A will be noise point, B will be noise point, C will be border point, D will be C, E will be C, F will be C. So this is the final methods we got after the calculation of minimum points numbers and epsilon 1.5. So here, this is another example that is called here the graphical plot or the points with the blue color which we contained in a clustering algorithm. These are the original data points. After applying to the DB scan, after applying to the density based clustering method, it will be clustered and point out 3 points. What will be the core point, what will be the board point, and what will be the outliers or the noise point. So here the green point that will be much more clarity or much more easier to retrieve. That's the point called the core point, and the blue point that is denoted as the border point, and the outer layers or a red point that will be called the outer layers or the noise point. So some more clarity, the data sets or the original data set we could filtered and clustered much more clarity. That is the concept called DB scan or a density based clustering. So advantages over this method is it does not require a priori specification of number of clusters. It is identify whatever the noise value, and when we clustering something we could identify the noise value, and we could we could separate the outer layers of the noise value, and we can form the clusters effectively. DB scan algorithms to find arbitrarily size and arbitrary shaped clusters. So DB scan algorithm, it will be find out whatever the size is the data set, the application will be or the algorithm will be applied to cluster each points, data points specifically or efficiently by using different shaped clusters also. Then DB scan algorithm, in case of very density or density range or a or distance range or a difference, the clusters it will be formed in different way. Then it will be data set that not be clarity, it will be make some errors also. That is the advantages and disadvantages of the DB scan algorithm. So DB scan is one of the algorithm which is used in the density based clustering algorithm. Density based clustering means we need to find out which point is adjacent to the another point, or which point we could form the clusters efficiently. That is called a density based clusters. It contains 3 points. One is core point. Core point means it would satisfy the criterion minimum of 3 points it need to required inside the circle, and also the one of the other parameter which is called the epsilon parameter, that is the radius which could draw the circle to mark the clusters point or the circle point to include different points inside that particular circle, and the radius which we want to draw the circle, it is called the radius or epsilon value. So that based on that epsilon value, we could draw or classify the circle values or the objective value, and depends on the minimum point we need to fix it, if it is core point, if it is plot point, or if it is noise point. Then after this clarification, we could remove the noise point or the outer layer point separately from the core and the board point. These are the clustering method inside the density based clustering algorithm. Okay, hope you understood. So density based algorithm, it is a clustering method which could be more efficient after avoiding the outer layer or the noise. This is the method which we call DB scan algorithm of the density based spatial clustering of application with the noise. Okay. Then the next topic is BIRCH, but it contains so many methods. So the next class we will discuss about the BIRCH method. BIRCH is again a type of hierarchical clustering. Hierarchical means it is a tree-like architecture. Initial case, it need to find out whatever the root node, and from that root we need to find out each leaf node. The condition is BIRCH is a balanced iterative reducing and clustering using hierarchies. This is the full form for the BIRCH clustering algorithm. So here we need to find out, after analyzing one iteration in the BIRCH algorithm, if the value is less than the threshold value, that is 1.5, and it could reach the maximum branch. One example is that when we consider the t value less than 1.5, that is the threshold value, and maximum branch it is nearer to 2. So here only, based on this condition only or criterion only, we could form the hierarchical clustering or a tree-like architecture. Maximum branch equal to 2. That is one root node, maximum branch is 2. Whatever the possibility we need to apply in the different problems, here only we allocated that the circle or the center root node, it could contain only 2 branch node, and threshold value it less than 1.5. For that, we need to find out one CFN, CF1. CF means cluster feature. So then based on this cluster feature, we need to find out the radius value. So that radius value, which is indicate whatever the feature we need to extract from this radius. So here the CF that will, or cluster feature that will be calculated like CF. Inside this angle bracket, n will be there. N is the data point, number of data points. LS is the sum of data points under consideration. SS will be the square sum of the data point under consideration. So these, based on N, LS, SS, we need to form first CF1 as the root node. And after creation of this root node, we need to again check another CF funds or CF points, CF2, CF3, CF4. Based on these, what are the data points which we can have on? Based on these, we could form different CF or cluster features, and based on this cluster feature, we draw the hierarchical structure. The condition is we can have only 2 branches inside the tree. So for that, we could find out some objects, and based on this object, we need to identify which CF or which cluster feature, and that cluster feature that could be maintained by or calculated by N, L, LS and SS value. Is it? This is the sample architecture which we can have, and here after finalizing all these values, we could have 1 root node and 2 child node. This is the condition we already fixed, like maximum branch equal to 2, threshold equal to 1.5. Based on the threshold only, we could find the CF value or cluster feature value, and based on this cluster feature, we will we will doing the algorithm of the clustering, BIRCH algorithm we could implement. Okay, so this is the topics for the today's class. After this, you just do one MCQ. Okay, you have to do one MCQ. I will post it on the slide itself. Okay. Hope you see the slide. Hope you see the QR code. Please unmute and say, this is the
No,
QR
ma'am.
code for the MCQ. Is it? Hope you see that.
No, ma'am, we couldn't see the QR code.
Oh, okay, okay. So I just want to share the screen. Now is it visible?
Yes, ma'am.
Okay, you can do that. From the attendance tracker only, I will put the attendance. Okay. For the WhatsApp, whoever the physical attendance or the OD attendance, please WhatsApp personally. Okay. Hope you see this QR code and all you complete it, then only you can mind it. From the attendance tracker, I will put the attendance.